Welcome to clickmyproject.com.
Our product actually is rapidly tunable dual comb RF photonic filter for ultra broadband RF spectrum applications. Let we see our product abstract. Our process will demonstrate a rapidly frequency tunable radio frequencies filters using microwave photonics technology for ultra wideband RF spectrum applications. A pair of electro-optic frequencies combo is arranged as dispersive tabbed delay line. The differential reductions configurations in the implementation of program infinity impulse response RF filters. Our photonic scheme enabled both fast frequency tunable of order of tens of nanoseconds and wide tuning process 7.5 GHz in below, with minimal variations of RF gain and passband shape. The low control voltage and linear relationship between control voltage and processing of the signal with time varying frequency content, while the differential reductions increase the photo current by a factor of 2 and suppresses common mode intentional noise. In the process, the RF system, the frequency tunable RF filters is now one of the key RF component and has been the exclusive developed by the electronics process. In the electronic process, various tuning elements such as ion gradient resonant RF microelectric chemical process, like for example MEMS sensors, semiconductor varactor diodes have been used the designing continuous tunable of RF filters. The RF filters have been widely and practically used because it's a wide band tuning range of purpose. The tuning the speed up and frequency maintains the process. And the RF filters we limited the time constant of the network bias networks. For this process we have used the 40 MHz frequency shift capacitance range of varactor diodes. In this process the filters tuning range of limited below 1 GHz. The filters requires very high control voltage and adjustable activate varactor capacitance and MEMS process. The control capacitance of the MEMS process in this scheme amplify requirement of the generations of high voltage control. In addition, the help of the high control voltage changes cause the non-linear tuning relationship between the filter frequency and control voltages. Let me see our process flow diagram. In our process we are giving the SR ratio for the input to the spreading ratio detector. In the detector is going to the output for the controlling the process of spectrum process. In the spectrum controllers getting from the signal from phase frequency detector, we have giving the phase frequency detector the two input of given. One is the reference clock and another is the output of digital controller oscillators. Thus the ratio of digital circuit which is detects the phase and frequency reference between the reference of clock and digital oscillator output signals. Then the clock generated output signals is a frequency of DCO is to be increased or decreased. The DCO is to be the increase or decrease the process PDF procedure up and down signal as the input and it given the spectrum controllers. After this process going to the delta sigma modulator. The delta sigma modulator is used to provide the triangular modulator waveform. Thus the DCO is directly modulated. The delta sigma modulator is implemented by using the integrator with the quantized circuit to provide the triangular modulated waveform. The delta sigma modulators are mostly used to provide the high resolution output signals. After this process we are using the digital control oscillator. The digital control oscillator with the delta sigma modulator provides the smooth triangular modulation signals. Thus the digital control oscillator is directly provide the efficient clock signals to delta modulator to provide the smooth triangular modulation waveform. Thus it provides the diode clock signals and it is given the PFT detectors. After we going to the final stage of frequency diode. This frequency diode circuit is used to diode the output frequency of digital controller and oscillator provides the output of diode clock signals to PFD detectors. According to this phase frequency detector provides a single variations of DCO as up and down signals. We are going to the final stage of the performance analysis. Thus, the whole digital spectrum is generated and the maintain the DCO generators fast relocked output of signals maintains the delta sigma modulator with the DCO provides a smooth triangular waveform output. Let we see our process running procedure. In our process, the spectrum process, we have designed the Tanner DDA tool. The process in the communication process, we have designed in the how the architecture is designed in our Tanner tool. The process, the design is completed in the cell 8 process, the architecture of the spectrum process. After the running the before we are going to the simulate the setup the simulation process, we have select the setup space simulation of cell process. I have transient Fourier analysis process. Click after the setup for the timing and the maximum time. What are the timing we have enabled the process, and what time we should stop the process. So we set up the process time, stop time, and the maximum time step, and the print start time process. We have given the process completed. We go into the cell creations. So cell new, we will create the additional of cell process in the same designing of the spectrum process. So we initially first initially for the inverter process, and how to give the input for bitwise. So last we have designed the spectrum process. So after completing the process, we go into the spice simulation process. This is very important for library files creating the process. So we should create the library for which our process is stored in the libraries. We creating the generic of the point to point library files in this mandatory. So this is a document. What are the tools we have? It the Tanner tool. The Tanner tool is already we have separate the library files in the, it will be there. So we select this path and library selections. After this process is completed, we are going to the start the simulation process. So we are going to the start in the process. The automatically will open the double edit for waveform generation process. It will be give the number for waveform output for the spectrum process output. So this is the output for the cell 8. We going to the split the process. So voltages, we are giving the bitwise for the voltage source process. First we are giving the voltage for the input process. So 0 on 1 0 1 0 1. The auto output for the up conditions for in up and down signals for the process. So this is the down process. So we are going to the zeros. I will take the 1 1 1 0 1 0 1. This is here 1 0 process. After same process, we go into the get the input for the spectrum controllers process. After giving the ADC process output for, so we go into the same process. It will show the output process for final output for the spectrum oscillating output for here. And also we go calculate the power calculations from T-space tool using the process. In the process we generate the timing for the process 5.82 seconds. The running the spectrum process oscillator process running the time maximum time. And then we should calculate the power calculation setup for the file and export is specified. What are the cell we create the export the file just for giving the export. The automatically the cell generations created for the T-space tool. This we will calculate the T-space for the process calculation process. Thank you viewing our website.